Hello reviewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about track ballast. So let's dive right into it. Now, why do we exactly need stones on railway tracks? Well, reality is that we are seeking something that is stable base for our tracks, because the moment you can call something a track, what does it inherently means is just rails where your wheels run and sleepers that are binding them together. Now, sleepers are doing the most important job here. They are making sure the distance between those two rails is fixed and the elevation is like done properly. And rails cannot actually transfer their weight properly, meaning if you have giant heavy things running on them, it will sink into the ground. So sleepers give it enough space where it's like, okay, I can handle it. Now here's the deal. Still not good enough. Sleepers do able to distribute a lot of the load, but still not wide enough footprint where it will not sink. So it will inherently sink, and we are looking for something that allows a very good base where you can like, I got this. And trains are very heavy and getting heavier. You have to understand this. Like even Indian railway trains are A, they are broad gauge, and B, they are heavy, and we have a dedicated system that we are building for dedicated freight corridor, and those are even more big, even more expensive. Not in terms of track width, but in terms of tonnage it can go through per axle, it's much higher. So trains are heavy. Like you have to understand it. They are idiotically heavy, and then also they are very frequent. For example, if you are building a bridge, you know for a fact majority of the time it will just be used for cars. The bridge does not need to be cut, but if it has to be built for trucks, it has to become expensive. Now you think of it that way. Now imagine everything that is going on top of it is truck. The cost goes exponentially higher. The same problem happens here. So we need something that is cost effective also, because again you have thousands of kilometers of it, and it must survive element, meaning it should not have the common shortfalls of like, hey dude, in summer it expands too much and it starts to create too much fatigue stress. In winter it shrinks too much, creates stress. And then in rain it catches too much water, it creates an issue on that. No, it has to survive element on its own without you needing to baby it basically. And it must stop vegetation growth. Now vegetation may not look intimidating for like a giant train, but here's the deal. Vegetations have roots have the ability to push things out, meaning if a big tree even on a plant stage starts to move things apart, if you have enough of them growing through, your track is like lol, it's gone, it will be out of spec. What does that mean? That simply means the gap between the tracks is not fixed. There is a tolerance there. Nobody is expecting the gap to be precisely within 1/100th of a millimeter. Everybody is designed in such a way that there is some slope to it. But what if it's this much? Yeah, your train will derail. What if it's like this much? Train will derail. So that's the whole point. That's why vegetation is a very serious enemy to basically tracks. Especially that's why you will always see there are unmaintained tracks which have vegetation, but like the tracks have become very saggy. So we use ballast. Now ballast are simply stone that we call ballast here, and they are crushed stone very specifically. They are never mined from a river basin or something like that. You never want soft and smooth rocks. You always want as jagged as possible. Now it must be irregular. You have to understand that we have the technology to filter out rocks based on their sizes, but that's never done on this. Meaning you inherently want rocks, let's say they could be as small as like 1 or 2 centimeter, could be as big as 3 centimeters to 5 centimeters. We generally want a good mixture of rocks. You never want like, okay, this big rock, that's it. No, some big rocks, no problem. Some small rock, no problem. Lot of mixture, awesome. That's the desired aspect. And it must be sharp edged, meaning it should not go through too many times in the rollers and all that jazz, so it does not become very smooth. That's a desirable aspect here. Many times if you ever had to walk on these sort of things, you're like, dude, it's a brutal. Even if you can have a very thick sole shoes, you still find it like, dude, these are very sharp, and that's by design. Now that sharp edges allows them to interlock, meaning they go like this. And when you interlock something like this, and you have hundreds of interlocking point every square foot of it, or every square meter of it, that creates an almost concrete like structure where it's like, dude, it's not gonna move. It has so many interlocking points. And it also allows water to drain out, because let's say water, it rains, it just sweeps away because there is more than enough empty space there. And it's very cost effective, meaning you're not going to bankrupt your country trying to build this. This is also another critical aspect. Like, why the heck Hyperloop is a scam? Simply because it costs too much per kilometer. There is no country that can afford like something that costs few $billion per kilometer. Japan did try that, but again, that's why you do not see maglev as a primary system. Shinkansen is still the primary system. You can try it, but good luck. All you're going to do is debt your country. So cost effective is a very critical aspect, and it's unending, meaning every time we have to create a new one, it's like, oh, where will get stones? We got this. Stones is not a serious issue. We got this. And they're also very good at stopping grasses to grow from it. Even if you do nothing to it, there is a very good chance no vegetation can directly come onto it. So that's the ballast. So how do we deploy these ballast or use these ballast? Well, rocks is selected based on the traffic requirement. For example, in case of India, normal railway will get normal kind of stone, but the stones that are selected for dedicated freight corridor will get much more oomph in terms of the rocks. Basically, it will try to get as hard rock as possible. Now, if you are trying to run a high-speed train, meaning anything traveling around above 250 kilometers per hour, it will generally, the bed thickness could be 0.5 meter. And you have to understand, while rock is not that expensive, but you have to understand, transporting rock is very expensive. Meaning you can have 5,000 tons of rock, no problem. Transporting 5,000 tons of rock is a very expensive thing. So laying it down on a track system, you have to be very efficient with it. Otherwise, your bank balance go poof. So in that scenario, 0.5 is the highest, and that's why many times people are ditching this sort of system for high-speed system. It's too goddamn expensive just the transport. Normal depth is 0.3 meter. Now be mindful, people have run simulation where they simulation and test where they made it even thicker than that. Outcome was it had a diminishing return, meaning it did not make any sense. So unless you have high speed, you will not see a half meter thick bed. Generally, you will see 0.3 meter thick bed. Now, generally, they also have shoulder. Now, this is a very critical aspect. You may see tracks like this, especially when they are being built, but this is not a finished track. If trains run on this, the track will dance away because it's constrained in z-axis. Basically, it's not going to go down. That's awesome. And it's not going to jump up because it's heavy, but it's going to slide side to side because there is nothing bounding it in that constraint. There is no constraint. Lateral movement is not constrained. That's why always tracks are buried, meaning you lay the bed, you lay down the tracks using machines, and then you lay more rocks around it, more ballast around it to constrain it laterally. Specifically, if you are making turns, at that point of time, you may find like, there is a bit more ballast in those sort of area. It's designed so it can absorb much more lateral motion. And again, without interlocking, it will just slide right by it. So it has to have that sort of system. And anytime you will focus on a machine, you will see like they are never like, oh, just put it on top of a bed. No, you have to almost sink it or, drown it basically if you're trying to add ballast to it. Depending on what works for you, what sort of machine you are using, that's how we deploy these puppies in real life. Now here's they may look strong, they are strong, but they are very fragile. They need way too much maintenance. You're like, wait a minute, why the heck stones need maintenance? Well, because of fouling. Fouling simply means things getting stuck there. Now what can be stuck there? Well, if you are in India, there's a lot of stuff, like a lot of vegetation, a lot of pollens, a lot of insects. Trains have a lot of moving parts that have like, grease coming out. Trains have toilets also. That's also flushing into the track system. So you have a lot of stuff, just junk stuff going there. Now, if enough of it, stays there, it can create vegetation, meaning some small, pollen will go there and it's like, hey, this is a fertile ground, I'll grow. And the moment you go from like top surface and to, soil below, which is like could be half meter or even like 2-3 meters below, the moment even a single root connection is made, this whole, track would be like absorbed in vegetation. It's surprisingly quickly. The first one will take very long time. It could even take years. But if it happens, you'll be like, poof, whole track is gone. Where was the track? No, forest ate the track. So for that reason, fouling is a very serious concern. For every nation that deploys ballast tracks, they have to quote unquote clean it. And otherwise vegetation will simply destroy. And this is a cleaning machine. Every country has it. Like this is, I'm showing an Indian example. I have provided a video down below, which is like much bigger variant of it. And what they do is basically pull the tracks, put an excavator below it, basically below the sleepers, and then just leap stones away, put it into a shaker, shake it very thoroughly, and have junk thrown out on the other end. If you are traveling in Indian Railway, many times you may find like stones are there, it's clean, but they have a line of junk, garbage, soil. It's like a dark material. It's like, why the heck is there? Generally that simply means it has been cleaned very recently. So you have to understand, without it, the vegetation will destroy this sort of track within 5 to 6 years. So you have to clean it, stop it from fouling. And again, sometimes you may not want to do something like this. You may want to inject herbicides, things of that nature, depending what you choose. Then you have to understand, while the stones are there, they are interlocking, they are still going through temperature cycles. While overall your size is not changing, but each stone is changing in itself, where it's going stress, low stress, stress, low stress. You have trains that are going bam, no bam, bam, no bam. Over time, it will damage it. So what does that simply mean? This simply means starts to shift out of alignment, meaning those tracks that's supposed to be like this, they're like little bit here. little bit down, little bit sag. So in those sort of scenario, you need to do what we call tamping. Tampings are machines like this. What they do is basically there is a rail inside the carriage that you see. It is going to pull the racks, and the carriage is very finely machined. Whereas like, no, I'm going to hold the rails, and this is exactly how far apart the rails should be, the like exact dimension, and then these tongs will go under the rocks and then vibrate it, so it retightens it, and then they lay it again. This also has to be done periodically, otherwise your tracks could literally become unsafe. It's like, it's a very real requirement. And the final issue is that over time it will become soft. Again, just from doing this, just from the fact of like, thermal expansion and contraction, rain, shocks of the trains going on, over time it's gonna become smooth. So you'll start with stones that are like very hard, very rocky, very edgy, and then over time it's like meh. And at that point in time, it starts to shake. So trains are no longer safe to drive at high speed. So at that point in time, you have to throw away the whole stone and lay a fresh stone. Like, this is a real thing, generally done around 20 to 25 years, maybe even sooner if it's a very high speed system or very high use scenario. So maintenance is very critical thing for this sort of system. So what we can expect in the future? Well, the reality is the lifespan is the biggest issue of rock sort of system. They barely last 20 years, barely. Like really lucky, then it will touch 20. Generally in some scenario, again, depending on location, depending on scenario, you may have it's like I never have to deal with about vegetation. Sometimes it's like, dude, I have to worry about vegetation every other year. Sometimes because of the use, tamping would become something, dude, every other month I'm tamping it because the rocks have become too soft, as in like too rounded, so they are no longer interlocking properly. So maintenance requires a time. The time leads to downtime. Downtime is a serious issue, specifically a single link. If you have dual link, then you can maintain one and then have like another one carrying the load. It will slow down the speed but will not stop it. But in some scenarios, it has to stop it. So downtime is very expensive for any network. And ballastless systems are very expensive, but they are stable for 60 years. Let that sink in. 60 years versus 20. And not to mention with a lot of maintenance. Ballastless system have almost zero maintenance. It's like, don't even think about it. Done properly, built properly, commissioned properly, you don't think about it until for 50 years. So that's the whole reality. And another aspect, it allows much faster train. That's why you will look at any modern Chinese high-speed train, modern German high-speed train, modern French high-speed train, they will always have ballastless track that looks like metro tracks. Primary reason for that is that cement is far more rigid in terms of maintaining the shape, meaning it's not going to go out of alignment over the course of years or decades that you are using it. Stones will just go sloppy. That's why we have to do tamping again and again and again. Here is like, set it properly with a proper quality control of concrete, it's done. You don't think about it. It's like, I got this. Concrete got this. So it allows a very high speed train, meaning if you want to cross that 300 km/h barrier, you have to go to ballastless system. Can you do it on a ballast system? Yes, but generally it becomes very unstable at that point in time. It's generally not recommended to push beyond a 220 km. 250 is like, you are reaching a point where nobody is like that comfortable. Again, it will work, but you have to do it like, tamping it too often, you have to clean it too often, you have to like, change. So at that point in time, maintenance cost will bankrupt you. So that's why people generally do not prefer that for high-speed system. And metro system, because they are going through basically densely populated area, noise pollution becomes a serious issue. And because you have stones that are inherently being crushed, every time a train is going, it's creating too much noise, and it's also creating too much dust, because those edges that are very awesome at holding it together, they are edges. They are not like, damn. They are like, so that inherently means it's gonna crack. The moment it happens, creates dust. Like, you will notice that, like, let's say it hasn't rained in the morning. Most of the dust is gone, but train is going at very fast. You say, where the heck dust is coming from? It's coming from the ballast. So noise pollution, dust pollution is a serious issue for cities. So generally they will invest on concrete. And not to mention, it also simplifies their operation. Their operation only includes test the tracks. If you have any faults, any cracks, any damage on that, that's it. And most of the things can be done automatically. So most of the time they are just maintaining it. And maintaining is very minor issue, unless something big happens like earthquake or things of that nature. But it does need very high capital investment, meaning it's almost like, you buy cheap, you buy twice, you buy expensive, you don't think about it for 50 years. So that's up to. Another aspect of a concrete system is, you will never find ballast tracks on railway bridges. Again, simply will not fit there. Tunnels never will fit there. So if you have concrete system, it give you one smooth ride everywhere. Like in Indian Railway, you will find it very odd. Like when train tracks are going normal way, it's like, okay, X amount of sound is there. The moment it goes to a like, let's say, bridge, railway bridge, because they are made of very high quality steel, it rings like a bell. It's like it's like very high noise is there. So if everything is concrete, then a noise platform would be exactly the same. And not to mention, smoothness of the train will be fixed. Whereas like, I got this. Tracks are like, I got this. So train engines can really push their torques. So that's the future. More and more countries are realizing. Now again, Indian government is like flat out aware of the cost sunk on this. So they are like, dude, we are not jumping. However, every metro that we are building is having this. And again, the bullet train network that is being built in India, that will have ballastless system. So this was my presentation on track ballast. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.